Let me introduce you to a revolutionary technology that allows you to create user interfaces that are interactive, responsive, and that work on essentially any platform and any device. This technology is called HTML. You may have heard of it before. It has been around for a bit. And you're probably familiar with how this typically goes down. You have this thing called the browser. You give it the address to the piece of UI you want to display. Browser makes a few calls, gets back HTML with the content and structure of your UI, CSS for extra vibes to make it all look pretty, and you can get pretty far with this. There are a few built-in interactivity primitives, like links and input elements, and that usually involves the browser sending that stuff to the server, and you get back more HTML with the next page. If that's all you need, perfectly reasonable. Every now and then, you want to have interactivity that's a bit closer to the user. Like in this case, a button toggling something in the UI. And you don't want this server round trip for everything. So of course you can do this by sprinkling on some JavaScript on top, right? Like the on-click handler here. And that's what it was invented for, right? The one good feature of all of this is just simple text you throw at the browser to make UI happen. So we can drive all of this from Swift today, either by running a static site generator and generate some files, or by using a proper Swift server and render this stuff out more dynamically based on a logged-in user or some database content. In fact, for this very use case, I made a package called Elementary about 1.5 years ago that helps you declare your structure, your HTML, and components thereof in nice idiomatic Swift. So what looks like something like this, and this works, but there are a few things that are maybe not so nice. So first of all, we, in our nice and typed Swift language, we plug in this, foreign JavaScript thing that defines behavior in a somewhat unchecked way. And maybe even more problematic is that this way of handling interactivity messes around in your UI imperatively, right? So in the small example, it's probably not too bad. But you can imagine if every little bit of interactivity messes around in UI elements directly, it can become pretty hard to reason about what state your UI is in. So you could imagine rewriting this whole thing to look a bit more like this, where you would have an isLeaving variable, and this body thing based on the isLeaving value would display this one thing or the other. And the button click handler here would be proper Swift code, just setting this thing. It makes it really easy to see what the state is in this component. But of course, we can't just send this thing to the browser. The browser has no idea what a Swift file is. So you end up doing what everyone's doing, and you grab one of those plentiful JavaScript front-end frameworks. They allow you to do just this. You create your UI as a function of state in TypeScript, usually. And the framework takes over rendering reactively and does its thing. That's great. But of course you have to surrender everything to these frameworks, right? That's how they work. And then because of developer experience and backend for frontend and server components, eventually you'll be running a lot of JavaScript on your server and everywhere else. Now, any true web developer will tell you, this is fine, right? It's no problem, JavaScript. It doesn't deserve the hate. And it's only mocked because it's used too much and really, oh no. Oh, this is embarrassing. I think I changed the slides before and the caches don't match the types. Let me clear the caches here. See, okay. Oh no. Might also be one of those skill issues I've been hearing about. Let's refresh a few times, that helps usually, and it's fine, people get used to this all the time. Let's just hope nobody forgot to await the promise. Okay, as I said, JavaScript is fine. But we are not here. we're not here to talk about JavaScript, right? We want this. So let's cut to the chase. How do we get this done? The answer includes, and you may have guessed this, WebAssembly. Why? Because in addition to JavaScript, browsers can run WebAssembly. Now, thanks to years of work of the wonderful people of the SwiftUI open source community and recent efforts by Apple and the Swift guys, we have fantastic support for cross-compiling Swift to WebAssembly. And the Swift SDKs on swift.org make this pretty easy. So that part's covered. Next up, browsers have this thing called web APIs. And those are the same APIs that JavaScript uses to mess around in the UI, react to events, fetch data from the network, store stuff, and read later for persistent storage, all that sort of thing. And thanks to another project from the SwiftUI organization called JavaScript Kit, we can interop from Swift with the JavaScript runtime and basically have access to all those APIs and can do whatever we want in there, or whatever the browser allows us to do, I should say. And then lastly, this is where I come in, we need an actual UI framework, right? And so I turned this elementary thing into what I called ElementaryUI to give you just that. So if we look back at the snippet from before, oh sorry, I forgot that. One more thing to make this, shouldn't say one more thing, it's a bit loaded term. But one thing we can have that was a recent addition to get the right Swift for the job is we can compile this in embedded Swift mode. And what that gives us is, if we're a bit careful with what we do in Swift, we can get tiny binaries, right? And this is a pretty important feature on the web. So if we look back on the code snippet from before, this is what you do to make this work on the client. And so, as they say in Brussels, et voila. And let's look at this in action. Okay. Big enough? So I will not spend too much time on the setup. This is basically what you get when you go to Elementary Codes. There will be a link at the end. And just click Get Started and get the demo repo. Just know that this is running the regular release version, ancient history, as Lava would say, 6.3. Xcode toolchain, no good. Make sure this is the release version of the OS of Swift.org version. And you don't need to know much. Basically, as any web project, it starts with an index.html file, which calls into this little script here. It's pretty empty otherwise. This little script here basically has this magic string that a build plugin just transforms into a Swift build with the SDK and the right version and the right, make it be a WASM file basically. Takes it, throws it in this little function that just hooks up this interop, calls into Swift main, and you'll never have to deal with this basically. So this is the Swift main entry point. I think we can go one bigger. And it's also pretty easy bootstrap that comes from ElementaryUI. And you basically say mount this thing in body. You could mount into any other element in the page, doesn't really matter. And in here we have a very simple component. Let's see, let's hope this works. There we go. And let's make this a bit bigger. And this is watched in the background, so we can say do this. Okay, good. So let's do, thank you. Let's do what we came to do and make a counter. So I can make a button. Yeah, that displays some text. It's hard to type and talk. Count. Count. And when I click it, I want to, of course, up the count. Like so. Let's see if that works. Of course it works. Let's make this a bit nicer. And make our own view here. I was kind of hoping for AI. I think the Wi-Fi is missing. I need to type this myself. Okay. And we can, of course, just use a binding. as you do in other popular UI frameworks for Swift. I think that's how you spell that. Let's move the button in here maybe. Yeah. So the state lives here, and here we use the counter view and pass in the binding. It's a dollar syntax. And this works. Let's maybe use environment variable, and to do so, we can extend this here. God, how do I do that? Entry. Let's call it button label. And it'll be an empty string. Now we need to provide this thing here. And we can't use key paths in embedded. So you need to use this little key trick here. But then we can set the button label to, I don't know, my counter. And then here, let's clean this up. Same thing, key path, button label, and let's use that here maybe. Let's see, that works. Cool. So we have environment values. Let's make this even fancier. Let's make a state here, my label, and let's do something. And let's use a standard HTML input element, type text. I don't know, maybe placeholder. Hello. And let's use the bind value thing here to bind it to our my label. And in the environment value, we'll pass down this my label. How's that for a test? Okay. And now I can do this, and that works. Let's maybe showcase what happens if this is empty. Showcase an conditional is what I wanted to say. There we go. Okay. So let's just display some text. Label, please. Okay, maybe let's let's put this in a p tag or something. Okay, so I can do this, and then it switches to the view as you would expect. I think pretty standard stuff. All right, how's for time? Good. Let's do one more cool thing. Let's add a wrap. I'm not sure if I can do this now. No. It's like old school. It's important to have a rocket. There you go. Okay, and use a few built-in modifiers to change this thing, like the offset modifier, right? So we can maybe use the count, I don't know, times 30. So I need to do this. And maybe do the same here. Times 20. Oh, that's the wrong direction, sorry. And there we go, our rocket flies up there. Now, of course, it would be cool if we had like a transaction-based change system that tracks changes to the state and can apply animations automatically, right? That would be fantastic. So... Okay, voila.
Wow.
I went pretty hard on animation, so you can do things like that. I don't know, make it bouncy and delay the speed. So the animations are calculated in Swift, all the Spring stuff. but are pushed down to the CSS layer, so it doesn't call into WASM on every frame. Pretty cool, actually. So now it's a bit slower. What should go? Okay, you can stack those things. We can maybe do a scale. I don't know, count up to 2 or 1. I don't know. Is that not how you spell that? Oh. Okay. Let's see how that works. Wait a sec. Where's the rocket go? Oh, wait a sec. How did I mess this up? Oh, I know. Because the P element is the whole thing, it pushes it out, right? So we need to say anchor point leading, bottom leading. Why not? Okay, there we go. And there we go. Animated the size too. Okay, and now for the moment of truth, not so much for this part, but whether SwiftPM didn't throw away the Swift syntax cache. Let's build this for production. So this would build in release mode with embedded Swift. It'll apply WASM opt, and hopefully in a few seconds we shall see how big it is. There we go. And here we would clock in at around 150 kilobytes for the WASM module. You know, not perfect, but it's definitely workable. I'm sure we can get rid of maybe 20 more kilobytes or so with a few tricks. But it's definitely you know, plausible for certain things to run in the web like this. Okay, looking at the time, I wanted to show you one last thing here. No, that's the same one. Okay, I'll just fly through this really quickly. The elementary UI also comes with a reactivity module with this reactive macro that's basically observable, but it works for embedded Swift. So you can define your class like this, and all the state that changes in there automatically updates your UI, right? For your view model types or whatever. In this case, it's this quote thing where you can say add random quote, remove quote. And the other thing I want to show you is in this, the way this view is styled, it uses those inline things I've been working on too, called elementary flow. We can't have VStack and HStack, I know, this is the whole story, but we can have something like flex column and flex row, and like those style modifiers where you have access to CSS in pretty comfortable Swift, right? So I don't know, just mess around with one thing so you see. We can just change these things in here and get a pretty good developer experience. And of course this is working like that. And one last thing, this is just adding elements to the child elements to the container, right? And there is this magic, if I find it, magic modifier that automatically, if you're in a transaction with a animation, tracks changes to the DOM and animates them. So if I do it now, it looks like this. And that's pretty cool, if you ask me. Okay. All right, so, sorry, back one. As you've seen, a lot of the fundamentals are there, but there's still a lot left to do. Things like we need a router implementation for the client side. Ideally one that works with server-side rendering too, so you can get the whole hydration story going. We'll need proper clean APIs for fetching data and using the web storage APIs to store state, and many other things, and all of that should ideally be embedded Swift compatible. Which brings me to my last point. I would very much like this to be an open source community project that's healthy for the long run. So if you find this interesting or exciting at all, please reach out, see me after the talk, reach out on GitHub, consider contributing code or money, sponsorship if you want to support financially. I'm sure if we help together, we can make Swift a first-class choice for the web. So with that in mind, I want to end by just saying, let's make it happen.